How does adding wax to 3D printing resin stop a jewelry mold from exploding in a kiln? Standard resins expand when heated, creating outward pressure that easily cracks delicate plaster. Take a highly detailed 3D printed ring, cast in wet plaster, heading into a 1400-degree kiln. With standard resin, the heat triggers a thermal transition. Before it burns away, it expands violently, fracturing the rigid plaster walls. But when you use a resin formulated with 20% micro-wax, the reaction changes completely. Because wax has a much lower melting point, it softens and drains out first, essentially hollowing out the ring model from the inside. This early melt creates a vital internal buffer space. As the remaining resin matrix begins to expand, it collapses inward into that newly freed space, rather than pushing outward against the rigid mold. During the final burnout stage, oxygen flows into the cavity, fully combusting those collapsed resin chains into gas and ash. Because the walls never experience that outward thermal stress, the plaster remains perfectly intact. It preserves micro details like fine wire patterns, tiny prongs, and crisp engraved text. And that delicate ring mold? It's now a completely flawless cavity, perfectly ready for a pour of molten gold.